All right, guys. So we're just looking at a general Venn diagram here. Okay, guys. And we know this part between it represents A intersect B. Cool. But if we look here on A, right, we can see that this part here that says 1 and 2 would represent A only. Okay. So basically, these are the numbers that are in A only and they're not in B. Okay. Now, these guys can actually be represented as A intersect B prime. Okay? And let me just explain that. Let me try to explain that. Let me just draw a rectangle here. Let's say we have A and B, right? So we have A and B just like in the example above. Then we have B prime here. Cool. A and B, but we're only looking at B prime. All right, guys, great. So this A and B prime, right? What I've done here is I've drawn the two Venn diagrams here. This one, it represents A, so as you see, A is shaded, and this one represents B prime, which is everything outside of B, right? So if you find the intersection of A and B prime, which is everything outside of B, and everything inside A, you end up getting A, which is this shaded region here, intersect B prime, which is this region out here. So you're going to end up with, when you finish, you're going to end up with this region here, which is just this part, A only. All right, guys? And that makes perfect sense because it says A and B prime. So we can see here that this section here, right, this shaded region here, not including the intersect, but this shaded region here, right, the same place I'm shading here, and this shaded region here are both common to both Venn diagrams, right? So if we want to find A and B, that would be the space between the shaded region here and the shaded region here, right? So the shaded region here and the shaded region right here ends up with this section, which is A only. So that's why A and B is equal to 1 and 2. All right, guys? Cool. It's not very hard to understand, but I just wanted to explain this as best as I could to you. That A only is equal to A intersect B prime. All right, guys? Cool. So let's look at another example. All right, let's look at B only now. All right, guys, so B only would clearly be the same region here, which is only in B, right? Not A and B, but only in B, which is the 5 and 6 here, right? So this part here would represent B only, right? And for B only, it would actually be very similar to this. It would be A prime intersect B, okay? And I'm going to show you down here with two Venn diagrams again, okay? All right, guys, so we're looking at two Venn diagrams again. A prime, in this case, for A and B, would be everything outside of A, right? So that would be the shaded region here, right? Everything outside of A. Cool. That's what A prime would be. All right. So let's just shade up here. And for the second one, A prime and B, right? B would be all the region that's in B, okay? So if we want to find A prime and B, we're going to end up with this region here because when you look at the shaded region, the only one common to A prime and B is this region here, this crescent period here, right? So A prime and B is equal to this region here, right? Just the 5 and the 6. All right, guys? So get used to that terminology for these sections, okay? This part here with just B is B only, okay? And it's 5 and 6. and A prime intersect B is equal to B only. All right, guys, that represents the numbers that are in B only, not in B, not in A and B, just B only. Okay. All right. Okay, guys, and the last thing we have here is this region outside here, which is the region outside of A and B. It would be the same thing as A prime intersect B prime, which is just equal to 7, 8, and 9. Okay, and let's try to represent this on the Venn diagram as well. Okay, just gonna show you on the Venn diagram as well. All right, guys, so if we're looking at these here, we're looking at A prime and B prime. We can see that A prime would be everything outside of A, the complement of A, and B prime would be everything outside of B. Okay, so when we look at this, the region that's common to everything outside of A and everything outside of B, we actually just end up with the section that's outside of A and B. Okay, so the region we end up with, I'm going to show you on the big diagram here. All right, so the region we end up with for A prime intersect B prime is just everything outside of A and B. Cool. So end up with everything outside of A and everything outside of B. So all we're going to end up with is 7, 8, and 9. Cool. All right, so that's how we get A prime intersect B prime is equal to 7, 8, and 9. Cool. All right, guys. So when we're working with Venn diagrams, I think those are the most important sections. A intersect B, which is the shaded region in between here, right? So that's 3 and 4. Then we have A prime intersect B, which is equal to 5 and 6, which is B only, right? Which is equal to 5 and 6. Then we have A intersect B prime, which is equal to A only, which is equal to 1 and 2. And then we have A prime intersect B prime, which is equal to everything outside of these two, which is just 7, 8, and 9. All right, guys. So knowing these would make life easier when you're doing these questions. Okay, they're really gonna make your life easier. So get used to them. We're gonna do some examples. Don't make it stress you guys. Just do the examples and get used to them because you're gonna use these terminologies pretty often. Okay, guys. All right, so let's look at another definition now. Okay. All right, guys. So that's it, and I'll see you in the next lecture. And remember to do your best, and God will do the rest.